Hello everyone, Darius here. Today we're going to examine the solutions to Round 8 and Round 9 of the 2019 Spacechem Tournament, Mean Sheets and Ascension. Mean Sheets at first looks like a fusion puzzle, and to some extent it is. But upon second review, one finds that your input is a 4x4 block and the output is a 4x8 block, and it becomes a puzzle all about space management. The output is cobalt, element 27. The inputs are carbon and nitrogen, elements 6 and 7. We'll take a look at the three main approaches to the puzzle and how they fared against each other. The first category of solutions I like to call C9 splitters. These solutions fuse 9 carbons together to form element 54, xenon, then splits it in half to create cobalt. 8 fuses plus 1 split to create 2 cobalts results in a minimum of 9 cycles per 2 cobalts. To make one output, you need 32 of them. This means that this method of making cobalt requires a minimum of 144 cycles to make enough cobalt for one output. Coming in 11th place is Zig. So Zig's solution detaches carbons one at a time and counts to 4, shifting the carbon sheet one row over and starting on the next one. When it finishes the sheet, red inputs another, so red is in full control of alpha input and processing. Blue counts to 9, then grabs a xenon output and splits to make 2 cobalts. This is then used to make the sheet. The sensor is used to detect when the sheet is finished. So why did this come in 11th place? Well, red is moving this carbon all the way from the 3rd row to the 8th row, and this is a very long fuse cycle at 14 cycles per fuse. We'll see that these solutions are primarily limited by how fast you can fuse the cobalt output. And with this, Zig comes in 11th place with 27,000 cycles. Coming in 10th place, Lazy Comet. Lazy Comet's solution detaches a row of 4 carbons and sinks every atom. Blue fuses and counts the number of fuses. It improves upon Zig's solution in that the fuse cycle is faster, but it adds cycles because red has to process the input into sticks, and it has to help out blue in processing the cobalt. The sensor here is used again to detect the finished sheets. With the faster fuse cycle, Lazy Comet comes in 10th place at 23,000 cycles. Coming in 9th place, Binky. Similar to Zig, Binky detaches carbon from the corner of the carbon sheet. However, the sensor is used to detect xenon, or count to 9. This time, blue is counting the rows of the carbon sheet and handling the alpha input, and the cobalt is handled quite well. Red counts the number of rows of cobalt made and outputs it when it gets to 8 high. However, it still takes at least 12 cycles per fuse and more for resetting the sheet's position, so Binky comes in 9th place at 21,000 cycles. Coming in 8th place is Sobotka. Sobotka's solution is very similar to Binky's solution. Red detaches the corner and fuses it into a ball. The sensor is again used to count to element 54 or xenon. Blue counts the number of rows and outputs it when it counts to 8. The main reason why Sobotka's solution is faster than Binky's is the smaller fusion loop. This loop here is on average 9 cycles before it has to reset the sheet. From this, Sobotka comes in 8th place at 18,000 cycles. We're going to skip forwards a bit to the 4th place solution with Darius 1. Darius 1 first inputs a sheet of carbon and moves this aside. From this, he inputs another carbon sheet, then fuses half of that into another carbon. If you're counting this, that's actually 9 carbons, and that makes your xenon output. From this, he makes a cobalt sheet. So why is this one so much faster than all the others? Well, this is because the 8 fuses required to make the xenon happen at 1 cycle per fuse, which is much faster than the previous 9 cycles per fuse. So with this, Darius 1 comes in 4th place at 5,700 cycles. The second category of solutions I like to call Hassium Fusers. This category of solutions fuses up to Hassium or element 108. This is 4 times cobalt. The solutions in this category are quite unique. One of them uses the 9 carbon to 2 cobalt method, while the other 2 use a 12 nitrogen plus 4 carbon to make Hassium. The next solution is quite a unique one. In 7th place, Sobotka first inputs a carbon sheet and proceeds to make himself a xenon catalyst. Sobotka then fuses 9 carbons to create element 108, which is Hassium. Splitting once regenerates the xenon catalyst, and splitting a second time produces the cobalt output. Red counts the fuses, resets the sheet position, and handles the alpha input. Blue handles the product, and the sensor is used to output. The increase in speed compared to Sobotka's solution is mostly from the smaller fusion loop and the fact that red is not helping blue with the cobalt processing at all, so both wallows are working almost all the time. Overall, a very unique solution. With this, Sobotka comes in 7th place with 15,000 cycles. Coming in 6th place, Resins. Resins approaches this problem by first slamming 3 nitrogen sheets into a stick. The sensor is used to count until that is done, which is right around here. From here, he inputs a carbon sheet and then fuses all this together to form a Hassium stick. Once that is done, he takes the Hassium stick and splits it once and twice to create his cobalt output. Note that once you split Hassium down, it creates xenon, and this automatically debonds it from the rest of the Hassium stick. This is also the first solution to only make half the molecule at a time, then finish it by storing the half-finished cobalt sheet in the output zone. A very nice solution, Resins. With this, he comes in 6th place at around 7,000 cycles. Coming in 5th place, Tough Thought. Tough Thought's solution is another unique one. Let's go over what he does. First, a carbon sheet is inputted. Notice that with this placement of bonders, it's not possible to debond this last bond of carbon. Now, but watch this. With the first fuse, he fuses this carbon into this one to make element 12, then fuses again to make element 18, argon. Argon has a bond limit of 0 and it automatically debonds this corner. Red then picks up this last carbon and fuses it in. Now, blue inputs a sheet of nitrogen and fuses 3 rows into it. The sensor is used to count and input a new sheet of nitrogen when it runs out. After 3 rows are fused in, red comes by and resets this nitrogen sheet, and the uppermost row is then cleverly used to make a stick of cobalt and add it to the output. The sensor is also cleverly used to help count to 8 to output the sheet. The only time that the blue wallow reaches this part and there isn't a nitrogen is after exactly 3 sheets have been inputted or exactly after half the output has been made. So a single flip-flop is used to output and input a carbon sheet for the next half output. Overall, very nicely done, Tough Thought. With this, he obtains 6,000 cycles and 5th place. The third category of solutions I like to call 3N plus 1C. This is the last category of the mean sheets solutions, which forms cobalt by fusing 3 nitrogens and 1 carbon together without any splitting. The solutions in this category distinguish themselves by using fast, rod-based fusion techniques of fusing 4 atoms in a run. One big advantage of solutions in this category is that bonds are preserved as you make sticks of cobalt. Therefore, less bonding is needed overall to create the finished output. Coming in 3rd place, Counterpoint. Counterpoint solution begins by inputting 3 nitrogen sheets to make rods of element 21, scandium. This is stored in the top right corner of the reactor. Then a carbon sheet is inputted and is fused row by row into the scandium sheet, with the finished cobalt being bonded to the other end of the sheet. The sensor is used to detect when the entire sheet of cobalt is done. And then this is stored in the bottom right corner of the reactor, just like so. When the second sheet is finished, the output is stitched together and outputted. As one can see, with solutions of this category, space management becomes crucial. After a counterpoint makes a scandium sheet, look at how tight everything has to be. There's barely any space open in the reactor because all these atoms have to take it up during the fusion runs. Overall, congratulations on 3rd place, Counterpoint. With this, he comes in with 5,300 cycles. Coming in 2nd place is Blue-eyed Rat. Blue-eyed Rat first makes a sheet of scandium just like Counterpoint. The sensor this time is used for blue to find out when the scandium sticks are done. Then, in a very similar fashion to Counterpoint, Blue-eyed Rat inputs a sheet of carbon and fuses it 1 column at a time to make cobalt, and bonds the stick to make a sheet. So why is Blue-eyed Rat's solution faster than Counterpoint's? The crucial difference is how they handle the carbon sheet. Blue-eyed Rat uses one downward motion to fuse carbon, then one upward motion to bond the cobalt. Counterpoint's solution, meanwhile, takes one downward motion to bond the sheet, then an upward motion to fuse everything together, but then he has to maneuver the cobalt sheet to the right side in a less efficient manner than Blue-eyed Rat. In other words, Blue-eyed Rat's method of moving the cobalt over and bonding it to make a sheet is just faster. With this, Blue-eyed Rat comes in at 4,500 cycles. Congratulations on second place, Blue-eyed Rat. In first place is Brookios. Here's how this solution works. Brookios begins differently by first inputting a sheet of carbon and splits off a column. A sheet of nitrogen is then inputted and fused in 3 runs to make cobalt. Red then comes over and grabs this leftover carbon sheet, and this nitrogen gets fused into this column of carbon. Blue then moves this cobalt over to make a growing sheet and reattaches this carbon. It then repeats by inputting another 2 nitrogen sheets. Every time a nitrogen sheet is inputted, 3 columns are used to make a stick of cobalt, while the last column is slowly added together to make a 4th cobalt stick. Red comes in with the last stick and bonds the entire sheet in one go before storing or outputting it. The main increase in speed comes from the more efficient fusion with no time spent on storing intermediate products such as scandium, and that bonding the sticks back into the sheet is done all in one go instead of one stick at a time. With this, Brookios comes in first place at 3,240 cycles.